Well, I'd like to welcome everyone to the topic Unraveling Network Audio. We're going to be talking about Maddie, Dante, and AVB. If you have any questions during this presentation, feel free to send them in a chat. For those of you that are on the Zoom side, for those of you that are public, you can send me an email at Derek, DEREK, at syntax.com, and we'll definitely get those answered. Okay, without further ado, let's get started. So today we are going to talk about three very common and very popular audio networking formats, and they are MADI, Dante, and AVB. Now, before we had these formats, we had, it used to mean analog snakes, multi-channel audio for live sound and broadcast and studio meant analog snakes, which carried a lot of hum and they were prone to ground loops and audio quality degradation, stuff like that. So over the past 20 years, probably a little more now, many companies have tried to standardize and do proprietary formats. The Audio Engineering Society, et cetera, have all tried to hone in on different formats that are used. And these three formats that you see now are probably the most commonly used. They're not the only ones that exist, but Dante, AVB, and Matty are all three very widely used today. And there's no hum or ground loops or audio quality degradation with long cable runs with these. So it's a huge advantage. There's also routing advantages and other conveniences that we're going to go through. Now, I want to share with you that this presentation is really not about one format being better than the other. It's really understanding the differences, what advantages each format has, what are some of the disadvantages that each format has, and to help you choose the right format. So I like to talk about MADI first, stands for multi-audio digital interface. It is a unidirectional data stream, so it works very similar to SPDIF and ADAT optical. So you have a MADI out and you have a MADI input. They're separate cables. Um, when we talk about MADI, we're usually expressing it in 24-bit 48K, and it's 64 channels. If we go up to 96K, it becomes 32 channels. If we go up to 192K, then it becomes 16 channels. And the cable itself comes in a couple of different formats. But before I get into that, why MADI? I mean, why is MADI still widely used if the industry as a whole is really going towards AOIP, audio over IP? And really, first of all, one of the huge advantages of MADI is that it's a point-to-point protocol. It can do very extreme low latencies, and it's very easy to use across short or long distances. You don't need switches in many cases, depending on how you do it. And for the last decade, it's used everywhere, from various well-known companies, the Olympics, Super Bowl halftime show, concert tours, Broadway, Cirque du Soleil. um, it's just used in a lot of critical live broadcast situations. Now, there's two types of MADI cables, and arguably there's really three, because you will find twisted pair Cat5 MADI, but the most common are these two, optical and coax. Now, the optical looks like this shot that you see here. This is a duplex MADI cable where you have this little connector attaching the two cables so you can insert them easily into the in and out respectively. But you can also buy MADI cable as a simplex version, which is just the one cable by itself. Also, MADI is single mode or multi mode. So when you're dealing with MADI, you want to know, is your MADI network going to be single mode or multi mode? The single mode advantage, which is widely used in broadcasts, allows you to go greater distances versus multi mode. A lot of times, if the type of MADI is not expressed, I'm never a big fan of assuming, but if you had to assume, generally speaking, multi-mode is more the common standard, and then you have to, verify that you have a single mode version if you want it. A lesser known fact about MADI is that you can daisy chain MADI devices, and there's a ability in the protocol to embed the signal. So I can go, like, for example that you're looking at, these are 8-channel microphone preamps by RME. These are the Octamic XTC. I can go out of one into the other, out of that into the other, and so forth. And by the time I get to the end, I'll have a total of 64 microphone channels that are all time aligned. And that can go back to the console, for example. So I can essentially create my own custom stage box in this way. When you do this with MADI, you have to set what's known as a MADI device ID so that or the system knows which unit was the first, which one was the second, and so forth. So the proper delay can be put on the signal. Now, MADI is very plug and play. It's a key advantage that it has. So you can simply plug and play these like any other audio device without dealing with networks or boot up time or anything like that. Also, there's no centralized configuration, and depending on your perspective, this could be an advantage for you or a disadvantage. Devices are all configured directly or via the manufacturer's remote control. MADI does have a very powerful feature, which is seamless redundancy. So you can have on several hardware MADI devices a primary MADI IO and a secondary MADI IO. And you can set your receiving device to basically look at both the primary and the secondary. And if something happens to the primary stream, then the secondary stream takes over. And the idea is to do this without it being perceivable by the audience. MADI's used in critical applications. Super Bowl halftime show is a great example. And that's just because with the Super Bowl halftime show, You have very quick setup time and breakdown time. It can't fail. It has to work. If something were to become disconnected and reconnected, it would be immediate audio. So it's a very safe format for critical applications. And a lot of times I share with people that when you have live and broadcast intersecting, usually you're going to find Maddie in there somewhere. So those are just some of the things about Maddie. The next format I want to discuss is AVB. Now, AVB is a industry standard by the Audio Engineering Society, so it's recognized as a standard protocol. Thus, it's free. It's not. There's no licensing fees to use AVB as a manufacturer to incorporate it. It stands for Audio Video Bridging. The technology has evolved over the past several years, and in the audio world, we're now on the AVB Milan, Milan. And Milan is a sort of a consortium of manufacturers who are trying to standardize the AVB technology as it relates to audio video and in the AV industry in particular. AVB is an open standard. So, there, as I said earlier, there's no licensed software or hardware. And a typical components of AVB is you have a talker, a listener, a switch, and a stream. The talker essentially is the output. It's a source on an endpoint, an end station as they refer to it, and it produces a stream that can then go into a series of switches and distribute it out to other AVB devices. And those AVB devices to receive the talker are referred to as listeners. It's an end station and it's a destination of the stream. It consumes the stream. And a good example of that might be an AVB capable speaker. Now, an AVB switch is actually an IEEE 802 compliant switch that complies to the AVB specs. So when you're shopping for your network switches to do an AVB network, you have to make sure that it is compatible with AVB. And you can literally do an easy search on Google, and you'll get, Biamp and other manufacturers who support AVB and their recommended switches. So you definitely need to be careful about the switch that you use. And I'm going to give you the reasons why that is in a minute. And while it might seem like a disadvantage at first, when you learn about what AVB offers and why they have this switch requirement, it actually becomes an advantage. So I'll go over that in a minute. Now, there's also the idea of an AVB stream. It's a data stream that essentially is passing through your cable, Cat5, Cat6 cable. Where things get a little different for AVB, say, versus Dante or Maddie, is that in an AVB network, you have a stream and you can define that overall stream into various sub streams. And those sub streams can be defined to have a certain number of audio channels. You sort of can think of it, if you want to think of it from an analog point of view, you have a bunch of snakes that are various sizes, 8 channel, 16 channel, etc. And then you encapsulate all those snakes with one big insulation, rubber insulation into one massive cable. The massive cable is the AVB stream, and all the little snake cables inside of it are your little substreams. So in an AVB network, you have the ability to define these streams, how many audio channels they're going to carry, and at what sample rate they're going to be. So that is a little bit of a departure from what we're used to with Maddie or when we talk about Dante. So in an AVB network, not very different from a Dante network, you have your talkers and your listeners, and they're all connected with Cat5 cable. You have switches because with AVB, while you can connect two AVB devices directly to each other, as soon as you introduce a third, you need to introduce a switch to distribute everything. So you would have microphones, and which would be talkers, and you'd have speakers and DSP IOs, which would be listeners and talkers, depending on whether they're taking audio in or sending audio out. Now, AVB is a time sensitive network. You can get hundreds of channels in an AVB network. Typical implementations of AVB, and there's no hard and fast rule here, so that's why I say typical, and it's very hardware dependent on what hardware we're talking about. But typical implementations that you're going to find out there are usually 128 channels of bidirectional audio. And those hardware devices, while it's a total of 128 channels, you might have to define 5 streams of 20 channels, for example, or probably more accurate, whatever 128 is divided by 16 or 32. So you might do 4 streams of 32 channels to get your full 128 channels. So that's where people get a little confused. So just wanted to cover that really quickly. Now, AVB will support sample rates up to 192. However, theoretically, you can do different sample rates on an AVB network, where other networks like Maddie and Dante, it's one sample rate across the entire spectrum. So this is pretty unique to AVB. Some of the companies that have incorporated AVB, Meyer, Adamson, D&B, L Acoustics, Biamp, Motu, Avid, PreSonus. There's others, but these are companies that many audio professionals recognize, and they have adopted AVB as their primary backbone for audio over IP. And they should be fairly plug and play once you connect them and define your stream number as far as the number of channels. Now, AVB uses reserved bandwidth, so other network activity does not disturb the AVB audio. So this goes back to the conversation about the switch. So one of the reasons that an AVB compliant switch is necessary is so that we can handle this reserved bandwidth. There might be installations where you have to use an existing computer network that has other network activity on it to also be your audio and video network. And this is where AVB becomes a big advantage over Dante, because it allows you to run your AV network on the computer network that's already doing other things, and the two shall not hurt each other. So there just might be a situation where you cannot run an entirely separate network for your AV side. You have to utilize the existing infrastructure. So if you're in situations like that, AVB might be the route for you to take. Now, the AVB protocol is deterministic, so the latency across the network is in fact fixed. As I said earlier, it's a time sensitive network, so all of the endpoints, the listeners and the talkers, are all time aligned. And because it's an open standard, it supports higher bandwidth with future devices. So as the network speeds increase in the networking world, AVB is ready and should be able to be very easily adopted in those scenarios. In theory, because of the switch, it should be zero configuration for AVB compatible network switches. So if you buy, let's say, a PreSonus or a Cisco or a Luminex switch, which are AVB compatible, you should have no issues with the audio or the video. So those are some of the things about AVB that you need to know. Now I'm going to show you some things about Dante, and then we're going to sort of compare them, and then we're going to walk through some solutions that you're going to want to know about. The first thing is, in the Dante world, we have transmitters and receivers. That's kind of what they're called. Same idea as AVB. We have outputs and we have inputs. Now, on the switch side of things, a basic layer 3 switch, very similar to the type of switch you might use in your home office, can be used. There might be some configuration necessary. There might not. Just depends on what you're trying to do. The Dante stream itself is a single data stream, similar to Maddie. And typically, if we're talking about a typical implementation, say on a mixing console or a stage box, we're usually dealing with a Brooklyn to Dante device, which is a thing that the manufacturer puts in. It's the actual chipset. It does at 24-bit 48K 64 channels. Now, that doesn't mean every Dante device is 64 channels. You can buy a wall plate that takes 2 inputs. It's Dante. You can buy a microphone. It's Dante. It's one audio channel. But normally when you get to the central portion of your Dante network, where you're dealing with a DSP device or a mixer or some central distribution point, each chipset, each Cat5 port basically is a Brooklyn 2 chip typically. And that would give you 64 channels at 48K, 32 channels at 96K, and 16 channels at 192. So when you're comparing Dante and Maddie to, say, AVB, the one advantage that AVB has is the channel count does not change because of using a higher sample rate. So if you have a piece of hardware that is 128 channels and you want to use it in 96K, it's still 128 channels. If I'm using, say, a Yamaha console, which is Dante, and I want to run my show at 96K, well, then I just take my console channels and cut it in half. So I need twice as much gear. So those are just some things to keep in mind. Now, Dante controller is another key component of a Dante network. And I actually neglected to mention in the AVB world that there is an AVB controller is also a key component. These controllers are software that you open up that allows you to discover all the devices on the network and interconnect them. Now, Dante Controller has a huge advantage over the AVB world because it's a standard piece of software that is the same no matter what manufacturer hardware you use. You go to the manufacturer's website who invented Dante, and their name is Audinate, Audinate, and you go to audinate.com and you set up an account with them and you download Dante Controller. And this is the key piece of software that you will need to basically set up your network. On the AVB side, there are typically AVB controllers that come with the hardware that you buy, and they are proprietary controllers developed by that said manufacturer. There's also some free software on the web. Hive is probably one of the most common, HIVE, that is like Dante Controller. You download it, you open it up, you discover the devices on the AVB network. You can even define the streams, as I mentioned earlier, and all of that. So, what makes the Dante world more convenient is Dante Controller is universal for all of Dante networks, easy to use, easy to understand. And people in our industry have gotten very, very comfortable with this. So the network example of a Dante network isn't much different than an AVB network. So you have your senders and your receivers, or transmitters and receivers, and everything's interconnected with a switch. Now, in a Dante network, it's 64 channels bidirectional. It's not unidirectional like Maddie, so it works like AVB. You got 64 channels going in and out, all with a single cable at 24-bit 48K if it's on something like a converter or a mixer that has a Brooklyn 2 chip in it. And of course, if we increase the sample rate, that's going to cut in half. Now, a chief advantage of Dante is how great a job Audinate has done bringing manufacturers into the family. And this slide is pretty old now, so there's probably over 500 companies that have licensed Dante and just thousands of products that incorporate Dante technology. The reason that's important is whether you need a mixer, a wall plate, a speaker, a microphone, a distribution, you probably can find a Dante version, which makes that a huge, huge advantage. Now, I want to show you what Dante Controller looks like. Dante Controller looks something like this. You open it up, you have your primary navigation tabs over on the top, and you have different navigation on the left. But most people are going to spend the majority of their time in the routing tab, where you're going to see all of your Dante outputs or transmitters on the top. You're going to see all of your receivers and inputs on the left, and that's going to allow you to expand and route audio from one to another. Dante does allow you to do multing, so I can have one output go to many inputs, which is very convenient. And it also gives me the ability to go into the individual device info, look at clock, network status, troubleshoot, firmware update, all that kind of stuff. But like I said before, most of the time you're going to be in the routing area. The last piece of the puzzle regarding Dante is Dante Virtual Sound Card. Dante Virtual Sound Card is a software solution for turning your computer network interface into an audio interface. And what makes that really, really cool is the ability to simply, for a nominal annual or a subscription fee, you can use this software. And it's good for simple recording and media playback from your computer to your network. We don't consider it suitable for low latency, redundancy, external clock, and doing high channel counts with an enormous amount of reliability. We actually were working with Audinate with a company called RME, and actually asked, why does Audinate, want to partner with audio interface companies if they're offering this solution? And since I was there talking about RME specifically, they were like, well, RME is going to give you low latency, you have redundancy, you have external clock, you can do high channel counts, you have the mixing function, and we'll go into that in a minute. But we obviously want to let you know that Dante Virtual Sound Card does exist and it is an option, but it's not one we always recommend. Last thing about Dante is that it's built and it's compatible to the AS67 standard, because it actually runs on top of AS67. So in theory, Dante and AS67 devices can be connected to each other. So as a summary, all these formats have their strengths, and it's really up to you, whether you're a user or a design builder, as to which format is best suited to your client's needs or your needs specifically. Obviously, there's expectations and budget concerns. Whether you have to use the existing computer network, or you can set up your own separate audio network. Those are things that are going to play into whether Dante should be used or Maddie should be used or AVB. So we created this nice little comparison of Maddie, AVB, and Dante. They both can do, Dante and Maddie can do 64 channels on a single Brooklyn 2 chip on the Dante side. The Maddie spec is 64 channels on a single Maddie in and out at 24-bit 48K. AVB is a little bit more independent of that, and you can have 128 plus channels at any sample rate. AVB and Maddie are open standards. Dante, there is a license fee for the manufacturer, and to some extent, there's a licensing fee, while pretty small, for the user. Maddie has the quickest setup time, which is why it's used a lot in live. The configuration and boot time is something you have to factor in with AVB and Dante. AVB has the reserve bandwidth advantage on the AOIP side of things. Doesn't really apply to Maddie. Maddie has the advantage that if the cable becomes disconnected, you just plug it back in and you have immediate audio almost instantaneously. Maddie's very plug and play. AVB, you have some configuration and management. For some people, it's an advantage. For others, it's kind of a disadvantage. It just depends on from what perspective you're working. And then Dante, you have Dante Controller, which is pretty convenient and easy to use. Maddie's point to point. Uh, Both Dante and AVB are a combination of switches and networking cable, Cat5, Cat6 cable. They all work on Mac or Windows. Typical uses of Maddie is broadcast live, some house of worship, not as much anymore, studio. Uh, AVB, you see in automotive, live, install, and other. And Dante, you see a lot in house of worship, live, install, and contracting. Okay, so we talked about Maddie and Dante and AVB, and we still have analog audio and we still have digital audio like ASEBU and ADAT, light pipe, and SPDIF and stuff like that. So what's the missing link? Because inevitably, as an AV professional, you're going to run into situations where all of these formats are going to collide with each other, and you need to be able to know what's out there to deal with that. So we want to talk a little bit about connecting anything with everything. Now, one of the key things of technology you're going to want to know about, and this goes back to the Dante virtual sound card discussion I was having a minute ago, is the Digiface series from RME. They make essentially audio networking to USB 3.0 solutions. Whether you're working in an AVB network, you have a Digiface AVB. If you're working in a Dante network, you have a Digiface Dante. Now, we go back to the Dante virtual sound card um, problem or challenge. And some of the advantages that these offer over Dante virtual sound card is word clock, global mixing, ultra low latency, redundancy, etc. All of that is possible. Also, these are bus powered, so you can connect them directly to the computer and they get their power from USB 3. Also, sample rates can go up to 192. The driver in these devices are the same driver that you're going to find in other audio interfaces from RME. So they support 128 channels of audio in both directions with ultra low latency and extremely good stability. They each include total mix effects built in on an FPGA chip, which is actually built into the hardware. And that mixer is an amazing routing tool. I think it's a 128 channel matrix mixer that allows you to route and sum and bus streams, whether you're dealing with Dante or AVB, into some very flexible ways, which you cannot do with a typical Dante controller. So once I use Dante controller, let's say, for example, on a Dante network, because this is also true on AVB, once I make the connection of a Digiface Dante to the network, I've just inserted this mixer. So it's like having Dante controller with faders and metering. And I can bus and route and sum signals and control levels that I can't normally do without literally dropping a Dante or AVB compatible mixer. So this is a huge money savings. Also, the reason the Digiface Dante and Digiface AVB are a key technology to know about is that almost inevitably on in most every AVB or Dante network, there's a computer doing some form of playback or recording that has to be dealt with. And this is going to give you a low latency, stable way to do it and give you flexibility, not just from the software side of the computer, but also all the other signals that are routed in and out of these devices using the controller. Last but not least, there's a suite of software features and benefits you're going to want to know about, like Total Mix Remote. So I can actually connect to the network remotely over Wi Fi. This is a LAN situation, not a WAN scenario, but I can connect to the network over Wi Fi or another computer on the same network and have a remote metering, remote control of the streams. I can initiate snapshots of different routings very easily. Also, there's a suite of literally hundreds of dollars of free calibration and metering software in the form of RME's DigiCheck that comes into play with spectral analyzers, phase correlation meters, high precision metering, which literally allows you to meter just about every Dante or AVB signal at a very precise, in a very precise way. Also, there's a surround audio scope as well. So if you're doing immersive audio, and there's noise and bit statistics. And there was a more recent release of DigiCheck in the last month or two that added even more capability. So all of this is available and comes really at no extra charge. So the benefits of Total Mix for an audio network is metering and remote control and level control, submixing, confidence monitoring, all of these things that we just covered. Now, those features are common to both the AVB and the Dante version. However, the Digiface Dante is a little unique because it not only does Dante, it does MADI. So it has BNC MADI as well as Cat5 Dante. It has primary and secondary Dante ports. You can use it as a switch and connect two Dante devices to this device as well as your computer and not need a switch. And you have a headphone slash line output that you can create a mix that you want to monitor. And last but not least, there's even an external power supply, which means you can just plug this in with no computer and do a one-to-one fully duplex bidirectional MADI to Dante conversion. Normally, we do a demonstration of this, but due to time constraints, we want to be sensitive to everyone's time. We also have for Linux servers and Windows. Let me be clear. The RME Digiface works on Windows, but occasionally there's going to be installations where Linux comes into play. And the Digigram LX Dante is a great solution for that because it provides 128 channels of bidirectional Dante to your Linux server. So this is great for installations like hospitals, institutions where the system is Linux based. Now, the Digiface AVB is not very different from the Digiface Dante. There is no MADI IO, but it's 128 channels of AVB. With it connects to your gigabit Ethernet switch. It's Milan compatible. It also has a line headphone out and Total Mix on board. Now, what about microphone preamps? That's another area that comes up when you're doing a network and converters and things of that nature. So, since we're in a connect anything to everything mode here, there's some microphone and converters that I'm going to show you. They all have this in common where they have some kind of remote control web interface. So you have metering, routing. Many of these solutions that I'm showing you also have digital connectivity like MADI and AVB or Dante. So you can interconnect these devices and use them as converters and digital patch bays all at the same time. So they're very powerful boxes. Uh, One I want to show you is called a 12 mic. This was introduced in January of 2020. In addition to being a 12 channel reference class mic preamp, it also is 128 channels of AVB and 128 channels of MADI all in a single rack space. It has other features that are important to installers like redundant power supply, both with the regular standard regular AC as well as DC connections. It even has ADAT light pipe, redundancy, all the things that you would expect to find. The AVB tool is the same concept, just 4 channels of microphone preamps instead of 12, but you still have the full complement of AVB and MADI and all of the other features that the 12 mic has. The other thing that the AVB tool offers that's pretty cool is that you have a separate 3 and 4 analog output. And using the web interface, you can route whatever audio is coming in to this device to those two outputs. Could be your studio monitors, for example. What about converters? A lot of times we're going to run into situations where we need to get analog or some form of digital to either AVB or Dante. So the M32 series is a great series to know about because we can convert MADI and AVB. We can get an analog to digital version, or we can get a digital to analog version in the form of an M32 Pro AD or an M32 Pro DA. We also can get an all-in-one version of the M series where you have 16 in and 10 out in the form of the M1610 Pro. This product just started shipping recently. And a really cool flagship piece from a company by the name of Ferrofish is the A32 Dante. You will find this product used on a lot of ESPN broadcasts, remote broadcasts, OB vans, live tours, and lots of different live events, studios, installations where you want to convert MADI or Dante or analog IO or all of it together. And it's a very cool flagship piece to know about because you have such a high complement of IO in a small package in a one RU box. Now, there's some installations where Dante isn't necessary, so you can get the A32 without Dante. You also can get the Pulse version, which is the same idea, just quarter-inch balanced analog as well. So this is all part of the Ferrofish family of solutions that relating to analog Dante, MADI, ADAT that you're going to want to know about. And like the A32, the Pulse series also comes with or without Dante or MADI, so you can get it in different flavors depending on what your needs are. Now, again, keeping with the theme of connecting anything to everything, we typically run into, or you may typically run into situations where you need to convert various formats and maybe even do sample rate conversion. So another piece you're going to want to made by a company by the name of Apsys. This is the multiverter, and there'll be more products debuting from this company with some pretty cool features later on this year. But the multiverter is a very powerful multi-format digital converter. All of the formats that you see on the bottom, with the exception of the Waves sound grid, are capable. You can convert. Now you can do full stream conversion, like convert 64 channels of Dante to 64 channels of MADI, or you can do what we call asynchronous sample rate conversion, where I can convert, say, a 48K Dante stream to a 96K AS50 stream. Or an AS50 is a format that you typically find with manufacturers like Midas and Behringer. So that can be a very useful feature if you're in that situation. There's also external add-ons like AVB and ASEBU that you can plug into the back and also add AVB and AS3 connectivity. Now, one thing that a lot of people don't realize with this solution is that not only can I do let me say it differently. Not only can I do one-to-one stream conversion, like all 64 channels of MADI to 64 channels of ADAT, but I also can do individual channel conversion. So if I wanted to convert Dante channel 16 to AS3 channel 3, I can do that. And that's done through the web GUI. So you can connect a USB cable to this and directly to a computer. You also can connect to this over Dante, just getting the IP address on your network. So very, very powerful solution as well. So what are some of the application setups that we can do with these products? Well, let's just take a basic one. So we have a computer in our situation, and let's say we're doing AVB. So we have a USB 3 connection to our computer running Mac or Windows. This Digiface AVB gives me 128 channels of potential infrastructure. It gives me 128 channel audio matrix with total mix. It gives me 128 channels of recording and playback. It gives me 384 channels of metering. It gives me DigiCheck audio metering and metrics, as well as total mix remote if I want it. Now that's just getting from the computer and whatever software I want to record or playback from out into the real world. Also, this is a multi-client audio interface, so I can run multiple versions of audio software on the computer and run it in and out of the Digiface. Now, in this example, we have an RME AVB tool, just literally hard connected with a single Cat5 cable right into the AVB port. And now we've added 4 microphone preamps. We've added 128 channels of MADI, as well as 128 channels of AVB to this setup. But we can also add a 12 channel mic pre as well. And we can also go to Dante. So I switched from AVB over here on the right. Now I've just switched to Dante. I still have my USB 3 connection. Notice we're now using the MADI connected to the MADI of the RME. And now we have Dante capable. So we have an AVB and a Dante network all happening at the same time. So this is extremely powerful. Now, if we want to add a 12 channel mic pre and more accurately depicted, I've done what we refer to as a MADI loop so that we can clock the mic pre to the Dante network via the MADI port. Because usually in a Dante network, Dante likes to be the master clock. Therefore, the MADI is clocking the internal Dante, and therefore the 12 mic is clocking the MADI. We now have the ability to do 12 channels of microphone in as well as line in. We also have 120 channels of AVB. We have 64 channels of Dante, plus all of the other digital IO that's possible on the 12 mic. We can add another 12 mic and create a MADI loop between all of them. And now we have 24 channels of microphone preamps, 256 channels of AVB, and the Dante. Now we can start adding a Dante device and a second Dante device, and we haven't even used a switch yet. So in this example, I'm just using the converters that I just showed you, but these could be mixers, these could be stage boxes, these could be really anything. It could be a biamp system that's running with a Dante card. It could be a QSys system. A lot of different ways to go here. I could even put a hardware codec like a Digigram ServLink on here and now broadcast and stream something on the internet. Very, very powerful stuff. Also, with these boxes, you can use it in a multi-room facility, and with Total Mix Remote in engineering, you can control everything. In some cases, you could even get rid of the mixer and have a multi-room facility all tied together. It could be a school with classrooms, could be a recording station, recording studios. It could be a radio station with a bunch of different small production rooms. Lots of different ways this could go. TriCaster from NewTek usually uses Dante Virtual Sound Card with some limited I/O. Another more cost-effective and more powerful way to upgrade the I/O to your video production on a TriCaster is boot up the TriCaster in the Windows OS, download the driver, and you're now adding the Digiface Dante to this situation, and you get far more I/O. Plus, you have Total Mix if you need it. Let's say a small house of worship or just a small room running some Dante. Now I'm doing a lot of these examples with Dante, but they could just as easily be AVB. I just want to be clear about that. But I could be running Dante wireless mics, Dante DSP, and literally connect everything to a switch and the Digiface. And if I want to, even use the Digiface Dante's Total Mix to be a basic mixer. Now, I want to be clear. It was never RME's intent to make Total Mix a live mixer, but it is possible. It could be used. It has some limitations, obviously, because it wasn't designed for that, but it certainly could be a very quick mic on, mic off, turn up the level, etc. All possible. Now, a larger house of worship or a tour sound situation might look like this. Either one of these scenarios, they're both very similar. All of your inputs are at the top. All of your destinations are at the bottom. You got your mixing desk in the center of all of it, your front of house, as well as your mixing, your monitor console. Because the Digiface Dante is both Dante and MADI, maybe I'm using a monitor console that's MADI, and then I'm using, say, a front of house console that's Dante. I have that flexibility because the Digiface Dante does both. And now this will handle all of my recording for the show. It'll also handle all my playback. So if I'm using Ableton Live or something similar to do playback tracks, all of that is possible with a single interface at a very nominal cost. What about personal monitoring systems? Maybe you have a MyMix system or something similar that's Dante. And while a personal monitoring system's main objective is to give the musicians the flexibility to mix, sometimes the front of house people, oh, that's probably not the right way to put it. The front line people, the singers that are on the front of the stage, don't have little mixers right there at their disposal like the band does. So many times those mixes are provided by somebody else, either by using another MyMix unit, or you might even use the Digiface Dante's Total Mix to supplement and do submixing if you do not have enough channels on your console. So it's just another way and another benefit of the Total Mix software as it relates to this setup. So it's just something to keep in mind. Also, let's say you have a lot of audio needs at the stage, sticking with a live sound environment. Because the Pulse 16 is all quarter-inch outs, you might want to pop a Pulse 16 DX in your solution because you have 16 analog outputs that you can go out back into the PA speakers through the amps, which might be living at the stage. You might also have the wireless IEM transmitters living somewhere down near the stage. So having this analog output capability that sometimes the stage boxes don't have as much outputs as they have inputs, this just adds a certain amount of flexibility. Also, you can use Total Mix to handle any submixing that you might need for these wireless IEMs. So it's just another way to implement not only the pulse, but implement the digiface. Let's say you have a high concentration of analog going on somewhere. Now, this diagram is showing a keyboard rig. It could be anything. It could be a press box at a Yankee Stadium, which is where some of these pulse units actually live. There are many situations where analog audio still prevails, and you need the flexibility to go from an analog input or output into an audio network of some kind. So the Pulse 16 or the A32 are perfect solutions for this type of situation. Also, using a Digiface Dante with either an M32 Pro or an A32, I'm sorry, a 12 mic, you could actually interconnect Dante and AVB devices very, very easily. Probably the last example, and by no means were all of these application diagrams everything that's possible. We just wanted to touch on some examples to kind of open everyone's mind. But maybe let's say a courtroom, an enterprise courtroom. And those are more and more AVB scenarios because of the video. And you might have a biamp system that is handling the video via the Tessera Lux and then a Tessera Forte for the audio. Then each courtroom looks like this. So here's an exploded view, and you got all the different microphones that are in this one courtroom, and that might be courtroom one. Then you have courtroom two, and all of this is tied together with AVB. Now, in a court scenario, you have court recording software that has to individually capture every microphone independently and timestamp it. And there are certain legal requirements that have to be part of this process, which is why court recording software exists. Now, they work very similar to music recording software. You have to have an ASIO driver audio interface. So we pop in a Digiface AVB. So it provides stable ASIO driver recording. It can achieve a high channel number. And we can get larger systems that way, and it gives us confidence monitoring and all the capabilities that go with it. So those are just some of the examples that are possible with those types of setups. So I appreciate everyone being here. If you have questions that have not been answered via the chat, we apologize. So I would just like to give you an opportunity to send those questions to my email, which is derek@synthax.com, and we will be happy to get those out to you. So I want to thank everybody for being here, and I hope this was very helpful and educational.